and most of all, thanks to our patrons, the main source of funding for the content. Please consider becoming a patron if you haven't already done so. It's patreon.com/smAsho. We've got a lot of things to do this year, and our patrons are the main folks out there helping us do them. Again, patreon.com/smAsho. All kinds of perks there, and tiers range from $3 a month to $15 per month. Patrons credit crawl is in order of lifetime contribution. We've got an interesting cosmology segment today, interesting enough to be featured in our title. So check it out. We're looking at HH46, and we're also looking at HH47. Now watch the crosshairs, folks. There's HH46, and there's HH47. What's the significance? They're Herbig-Haro objects, which are a type of star which is encased in a massive cocoon of dust, and there's all kinds of activity going on. We're looking at it right now on the 2 mass, which is infrared light, and these stars appear to have hollowed out an area around them. If you look at it in optical, there we go. How about that one? Nope. All right, so there's a really good optical band, and you can see that void that seems to be hollowed out around those Herbig-Haro stars. And you can see some filamentary stuff going off in this direction, and a void, and then some filamentary stuff in this direction. There's an article about it today on scitechdaily.com. Herbig-Haro objects. So these outflows of matter are about 10 light years across, believed to be ejected from the newly born star and violently propelled outward at speeds of over 150 kilometers per second, about half of the current solar wind speed. So some very fast-moving dust there associated with those Herbig-Haro objects, HH46 and HH47. Originally, it wasn't believed that there were 2 stars there, but one star was discovered in the dust, and yada, yada, yada. You want to read more about it, head to scitechdaily.com. The title is Tantrums of a Baby Star, Herbig-Haro Objects. And that's a great composite image there from the Hubble Space Telescope. Let's talk about the way things form. Now, it's not known fully the way planetary nebulae form planets, and also we don't really know how stars form either, but in any case, we're talking about planetary formation right now. Let's assume the star is already there. We've noticed that through many, many experiments in microgravity that gravity does not seem to cause things to accrete. And one of the things that we've noticed is that spin polarization causes glass beads to stick together in microgravity. So what's the significance? Well, the beads form into long strings of glass beads in microgravity without any sort of forces on them, at least any significant forces. And it all has to do with the charge of the elementary particles. So all of these atoms and molecules sort of have their own magnetic fields, and it's believed that they align each other in these polarized strings in order to form into these, well, we don't see them accreting based on gravity. Let's just say that. There have been many, 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 many experiments in space trying to get things to accrete with gravity, and it doesn't seem to work. However, polarization of glass beads is a thing. I looked for an article. I couldn't find it today. But here's another interesting article, A New Way of Forming Planets by the University of Zurich. And what you're looking at there is an artist's impression of a quote, accretion disk, a protoplanetary disk with magnetic field force lines. And it's possible that there's some sort of a limit on planetary size because of magnetic fields. So some new models have recently come out. So maybe have a read on this article. It's kind of interesting in that now they're using not only gravity and inertia, but they're also using magnetism to create models of planetary formation. So now this is basically just about models, but just the fact that anybody is taking into account the magnetic fields within the protoplanetary disk is a big deal. So maybe check out this article if you haven't yet. As we're seeing astronomy, astrophysics, cosmology, etc. rewritten before your very eyes, and thank goodness, because it's been a mess. Let's talk about one more object. It's Cygnus X3, the massive X-ray binary, which is the brightest intrinsic object visible in the Milky Way galaxy. It's known as the star Deneb. It's part of the Summer Triangle, and indeed Deneb is the other end of the precessional cycle. So Deneb actually becomes our North Pole star. What we're looking at here is the Chandra Map. This is an X-ray image of Cygnus X3. I don't think this one shows up in infrared. Actually, it does show up in infrared. There we go. There you can see Cygnus X3. And what you're seeing here is actually these are infrared radio jets. So what you're seeing here is, let me make sure I have this on screen. What you're seeing here is one jet pointed directly at you, that's this blue one, and one jet pointed away from you. And that's because this thing is emitting this jet, which is sending cosmic rays all the way to Earth. Now, the distance to Cygnus X3, aka Deneb, is very contested. We believe it's somewhere between 1,800 and about 12,000 light years. But this jet is able to send protons all the way to Earth. It's one of the only known cosmic ray point sources. And I'd like to just make a quick point here about precession. So when you spin a top, let's say this is a top. As the top spins, the axis wobbles. That's what we mean as precession. All objects precess. So if there is a catastrophe cycle, and it is associated with cosmic rays, it's most likely coming from Cygnus X3. If you weren't aware, we're glad to inform you of this. There's a whole forum section on it in our Cosmology forum at smashomash.com/forum. More on this later. And speaking of moron, all right, I'm not going to say anybody's a moron, not today. But if you'd like to follow the X-ray transients from Cygnus X3, well, it's in an extremely loud X-ray state right now. You can find it at the Neil Gorell Swift Bat X-ray Observatory. There are the X-ray transients from Cygnus X3, massive X-ray binary, consisting of a huge Wolf-Rayet star, which is like 1,700 times the diameter of the Sun. It would be larger than Mars's orbit. If it was in our solar system, you would be inside of it. So there are the recent transients from it, and you can see it's in quite an X-ray loud state, as 0.04 is way up here on the historic graph. That's about 15 years of data. 16 years of data going back to 2005. And that's today's Cosmology.